Hello, everyone. My name is Oliver Wierzbicki, and this is my biomechanical combine analysis. The subject for my analysis is Naji. Naji is 23 years old. He is 5 feet and 7 inches, and he weighs 165 pounds. He's an athlete here at Lewis University. He runs track, and he specializes in 100 meters and 200 meter sprints. In terms of medical history, the only major injury that my subject had was spinal fusion. He has fused L5 and S1, and from some additional observations, the subject is right side dominant, so right leg and right arm. However, he uses his left leg to push off the block in the competition. So what I decided to evaluate and analyze is the agility performance of my subject. Just because braking and changing direction, I believe it's not the biggest strength of his since he's sprinting, right? He's used to that linear motion, that full speed um, performance rather than braking and quickly changing the direction. And the exercise I focused on the most is 5-10-5 drill, just because the angle and the structure of the exercise was really nice to record it. Everything happens in basically one line. However, the subject has to change the direction a couple of times. He has to brake and turn full 180. So I believe this is a good choice of exercise to start with. So the first mistake visible on my subject video is the improper braking technique. Here we have a picture comparison, and according to Keybench Training, and Keybench Training is a YouTube channel that helps to prepare to NFL combines. Transferring weight to the outside foot causes loss of balance and time, which is of course essential for performance in agility drills. In this frame, we can see the two braking positions. First, of the trainer that explains the right technique, he is going to take off to the right side. Like if we're looking at him right now, he's going to ride to the right. So the inside leg is, we can see, fully bended. Most of the weight is transferred on that leg, and the leg on the outside is just there for support, just to reach the cone basically. But then most of the weight is in the center or even closer to that inside leg. And this in order to maintain the control. This is how subjects should stay, and then push off with that leg that's on the inside. So we can see on our subject, Najee is braking there with his outside leg. Basically, in this frame, we can see very nicely that this position is very risky for any injury. His ankle is really close to he's really close to roll that ankle here. Maybe a little bit more of force or tension there, and we could have a potential injury. So we can easily see a mistake there. So according to the study done by Gonzalez Fernandez, agility training improves explosivity but has no impact on the speed performance. So the speed were compared for that study. They're called long distance speed, but they measured basically 40-meter dash, and the short distance for the study was just like the count exercises, like barely any acceleration. So as we know that the agility training is not the main workout, not the primary workout that the sprinters will use as they need basically max speed rather than quick change of directions. So the subject, because of that, is well developed in sagittal plane in only straight line of motion and only one, as he doesn't have to take any turns. So the acceleration, deceleration, and all the muscles involved in those will be really nice developed, but only those muscles, as I mentioned, he doesn't have to change any directions. So here we can compare the sprint and agility drills. So in sprint, once again, this is a straight line motion, and mostly involved muscles will be hip and knee flexors like quadriceps, hamstring, and gluteus maximus. Of course, there's many more, but primarily muscles. And we know that mm, those, since Naji is sprinting, those will be developed pretty nicely. However, agility drill takes place in various different planes of motion. There's turning involved, twisting, changing directions. So a lot of lateral movement muscles will be also involved, like gluteus minimus, TFL, and adductors, which will be technically they should be slightly more weak because of they are not used as much as quadriceps and hamstrings. Another visible issue is the body shifting from side to side in that straight line between between the cones. So here in the video, I highlighted two lines that we can see that the subject's body is basically bouncing from one line to another. And we can see like the shoulders are shifting from side to side, and the wide base of support is needed. His feet are also following the same pattern of basically reaching the lines on each side. So basically, we can see that the subject is doing small jumps from side to side rather than completely straight takeoff. So here we also can see the that the feet is the external rotation of the feet on the ground. This is not the right placement, and I compared also to the line of the direction to see how much, more or less, just to have a visual representation of how much of the angle that feet is landing rotated outward. And also the arms movement. The arms movement is across the body, across and away from body, is a mostly lateral movement rather than forwards and backwards. Here we can almost achieve on this frame, we almost achieve 90 degrees of separation from the trunk, which is not ideal. This is not what we're looking for in terms of running. So now to create an idea, here we have a comparison to a professional sprinter. So we can see the arms are going almost straight, and the only angle that appears is basically the angle of the camera, but the almost straight back. There's no side to side movement at all. The both feet are all the times are pointing straight in the takeoff, and we can see a little bit further in the sprint there, all the time straight. And of course, the body slightly moves to the side. Um, Slightly moves to the side, but it's because of the power input. It's not like our sprinter here on the video is jumping from side to side. But like we can still see that the same line and trajectory is maintained. And to compare with my subject is jumping from side to side, and it more looks like maybe hockey players or ice skaters. We can see that movement a lot. It's much more movement, side movement rather than straight in line. So as we know now, like these factors take place, are those issues related to the lack of balance that my subject experiences because he's not used to agility and changing directions, or is it just because this is his running technique, or that's how his body positions when running? So to make sure of that, we are comparing the video of my subject sprint. I highlighted also here in one frame. You can nicely see it. We have a takeoff, then the frame on the third or fourth step, no, second or third step of the sprint, and we can basically see the same issues. The feed is still the lowest two lines. Green lines is the feed, and also to compare with the direction of running, also is rotated outwards. The hand movement is also to the side, and even we can see the trunk is slightly bended to the right side in this case, when pushing off from the right leg. So this is also I interviewed a little bit my subject, and he confirmed that this is something he used to work on a lot, especially in high school. So this is nothing new. This is long-term issue. We can also see that the left knee drives slightly to the inside. I didn't highlight that, but it's pretty much visible if in that stopped frame that his left knee is driving inside and his feet is more outside, than the knee is not a straight line. So the most visible issue is of course the arm movement, because if we look at the feet outward rotation or like the body tilt, these will be small degrees, small inches of the change. However, the arms movement is the widest, most visible problem. However, it's not the cause of the issue, but the result. Having in mind the perturbations in the gait and the amount of time that our subject put to change those technique mistakes, it can basically prove us that the problem is rooted much deeper than just movement arm that could be fixed just by getting used to a different movement. Basically, what it means that all these moves that we can see create a chain result because the body tries to go back to the midline from getting pushed away to the side. So one hypothesis is the weak gluteus medius. According to Afshrit, medial lateral gait perturbation is related to weakness of gluteus medius. Because of that, body has to use alternative movements like lateral arm swings or inward knee drive as a chain reaction to maintain the balance. Exactly, maintain the balance, prevent from falling, and also to get back to that midline. As we take, let's say we took that step slightly to the left and we try to run forward. Now we have to not only go straight, but we also have to jump slightly back to the right in order to maintain that lane. So the author concluded from the study that this issue can be controlled by activation of the muscle of the gluteus medius. So for the study, the author focused on shift of the weight from side to side, which is the exact issue we're looking at, and feet positioning, the outward rotation of the feet. So like outward rotation of the feet, and also the widest stance to present, of course, to help the body not from falling. So what would that weak gluteus medius create? What will happen? Basically, the gluteus medius is responsible for holding our hip straight when we lift our leg. That's what the gluteus medius would be responsible for. One of the actions. So the weak gluteus medius or not active would cause a hip drop when only one leg is in contact with the ground. On the right side here, we can see basically how the body would position and the hip tilt when the gluteus medius is not holding the hip straight. And compared to that left picture, is basically the same position we're looking at, but just of course on like the other side. So our scheme here is standing on the left leg and Najee is pushing off the right leg, but everything is looking basically exact same, which could potentially confirm our hypothesis. Also, we have to consider the spine fusion, just because that lower vertebra are most likely have less mobility because of the fusion. Um, our subject cannot recover from that imbalance, from that tilt, just by curving the back. So the only thing uh, the body can do at this point is has no other like remedy than just fall to the side. If the ground is uneven and we cannot do anything about it, the body will just follow the tilt. So that's why uh, our subject has to move the arms to recover from that position, as well as place the feet more out wide. Of course, not to fall down because we try to achieve the best sprint possible. Another potential cause, which has really similar outcomes and results, would be the losing balance because of the weak abdominal muscles. And the lack of strength of in the trunk could lead to the chaos that body cannot control. Too many things, movement, too much power, and just we lose the balance, and body is thrown all over the place. So to confirm that hypothesis, weak abdominals basically would mean anterior pelvic tilt, which we all assessed in the lab. So we also checked that on I also checked that on Naji, and he's not close. I would even say he's a little bit more to forward into posterior tilt rather than arterial tilt. That's why I discarded this hypothesis. I didn't follow that lead. So to confirm the hypothesis of weak gluteus medius, I decided to go even one more step back and look at Najee's walking. So here in the video, we can perfectly see that as soon as Najee picks up the left leg up, his left side of the hip drops drastically. It's super visible even with the hoodie on. Basically, that part of the hip like all of a sudden turns off, and the right side of the hip goes up, which will confirm that the gluteus medius is potentially weak or is just not being activated enough. So how can we correct this issue? So according to the previous article, um, to correct mediolateral gait perturbation, it is necessary to activate the gluteus medius. However, using the exercises that will just strengthen that muscle might not be necessary, or not necessary, but might not be as effective, as we can see that the body already adjusted not to use it. So if we just go in the gym and we start to do like kicks, glute exercises, they might not even help us, just because body is already used to doing some extra work just to leave that muscle inactive for some reason. So the article effect of log rolling position on hip abductor muscle activation during side leg hip abduction exercises in participants with gluteus medius weakness demonstrate that sideline hip abduction anterior rolling is an effective way of activating gluteus maximus, together with relaxing and turning off that TFL. So here on the picture, we can see how this exercise would look like. We lay on the side, we abduct the leg up, and then we slightly tilt, like roll our body forward. We have a visible roller, half roller, in front of our patient here on the picture. So that would be our goal, to touch the roller without letting the leg drop or any other like part of our back to get up or do any extra movement, just to control it nicely to activate that gluteus medius. Another exercise is develop. It's nice to develop the neuromuscular activation when in position of running. Of course, laying down on the floor might be completely different to when we're actually standing up. We have to push off that leg. So here we can see a really nice exercise with elastic band, where the elastic band is either pulling our leg medially or laterally, and with that elastic band on our ankle, what we're gonna do is we're gonna pretend like we're driving our leg forward, nice and slowly to control that from moving away. We'll keep that knee nice and straight, also the ankle nice and straight to control, and to this way trigger our brain to know how to activate those muscles that will keep our legs in a straight position. And these are my references. Thank you for watching my video. I hope you enjoy it. I hope I will get a nice grade for it. And if you have any questions, please don't be afraid to ask them. Let me know if I can help you with something else.